Hello, everyone. It is March 5th, 2024. It has been a while since we've had a libhal meeting. We're still trying to figure out a new time for it, but this is just a temporary time, unless we like this time. So let's go over the agenda. I had a couple items on here that I wanted to talk about a while back and just completely haven't had the opportunity to talk about it, so I want to talk about it. So, talk about the thoughts on async, thoughts on high speed sensor interfaces. We'll go over libhal's new error handling system. We'll go over C++ exception handling techniques. We'll go over libhal 3.0 migration progress. I'm really excited to talk about libhal bootstrap. And then finally, we have libhal as a walled garden. And I'll really go into that one when we get there. The first two are going to be pretty simple, only a few bullet points. Thoughts on async. Should libhal have an async story? And I've seen other projects really work on this and think about this and really, strategize and all that stuff like that. And I'm starting to feel like the answer is not really. At least, yeah, I would say not really. Maybe, coroutines can have their place and people can use them for whatever they like to do, but I don't know if it's the right thing for us to make that for people and their applications. The one issue of not having this is that the world will make their own. But then again, maybe we can just kind of try to tell people not to do that. For example, I was kind of told that when it comes to Rust, their version of this would be Tokyo, where Tokyo is kind of taking over everything because Rust itself didn't create. They created all the systems to make it happen, but they didn't actually write their own async library, causing everyone else to use Tokyo. And that might happen with libhal too. But I think that you also have to think about whether or not that happens in Go. So Go has been touted as like one of the best systems for concurrency. So everyone talks about how good the concurrency model is. And the concurrency model is simply, as far as I can tell, use threads. You do Go on stuff and it just creates another thread. To me, I like that. That's really cool. But like, in a way, I was like, oh, I was wondering what this concurrency model really was. And I was like, oh, you just spawn off another thread. So I'm like, that's cool. And they have everything that FreeRTOS has. They have semaphores, mutexes, queues. They call them channels in Golang. We call them queues in FreeRTOS. Basically, a lot of the constructs that FreeRTOS has, Golang pretty much already has, and people love it. So if creating a new thread for things and having the same type of behavior that Golang gives you is what people really like, that's actually trivially easy for us to accomplish versus trying to figure out how we want to do async, because there's a lot of different things that go into how you would want to do async. But when it comes to threads, you just make a new thread and the thread does what it needs to do. So that's my opinion when it comes to async. Thoughts on high-speed sensor interfaces. So first thing I want to talk about is what exactly are high-speed interfaces? And I don't remember if I talked about this before. I don't think I have. So let's take a look over accelerometer over here. So accelerometer has a couple of, really just has a single function. It's called read. Returns back g-force x, y, and z. This is a floating point number where 1 is equal to 1g in a particular direction. The exact direction of the accelerometer relative to whatever is placed on is not encoded in this thing. It just gives you back what the accelerometer itself reads. Now, we're asked by Davi, like, hey, could we have something that's more high speed? For example, having to call this virtual API nonstop seems like it'd be very wasteful, and it is. It would not be very fast. So what could we do? Well, if you could give a buffer to the accelerometer class, to some other high-speed accelerometer class, and it could fill up that buffer for you, and then give that back to you, similar to how UR operates. So if we go over to serial, you can see that what we do for writing is that we give it a buffer and it writes it out, and then when we want to read something back out, we give it a buffer and it fills it up. The problem with just kind of filling up your buffer and all of that is that when it comes to with serial, it's easy because everything's a byte. I made it very clear that everything's going to be a byte. With accelerometer, I don't know what to really call or even have the data types for. In this case, we use floating point numbers to erase away things about like the number of bits or really the format of the acceleration data. But when you have to fill up a buffer, what do you want in that buffer? Maybe you just want the raw data, but you have to convert it at some point, I would assume, or maybe you have to have some sort of conversion in your code that knows what it's dealing with. You could fill up the buffer and then have it do the process of converting all of the entries over to proper read types. That could work. Do you need extra buffers to support the... If the user supplies you with a buffer of read type, can you reuse that buffer that they gave you to hold that information? There are cases where a floating point, X, Y, and Z, maybe the data that you're getting is actually somehow bigger than that or different than this and can't just reuse the same space. So there's a lot that goes into how the memory is structured that gets in the way of how a high-speed accelerometer or other systems could work. Not saying that we can't do it. I just think that it's a difficult problem to solve, and it's kind of along the lines of solving the display problem. We have a student working on this problem right now, which is how to create a generic display. And one of the problems is that displays all have different memory formats for how they structure where a pixel goes. They're not all consistent. So we have a lot of discussions about like what APIs even make sense that are performant and all that. So that is pretty much what they are and also what the problems are. And the main problem here is what data types do you choose and how do you make that all work? And how do you make that work in a way that's generic and gives the user enough control of the creator of the library as well as the user of the driver enough control to be able to meet almost all of their needs. So yeah, if there's anyone who's interested in this particular area, hit me up and we could talk about it. All right, so the part I'm really excited about, libhal 3.0 is actually released. It's available. You can go to it. We can actually do libhal, and go over to, well, it's output pin. I don't want to go to output pin. And bada boom, bada bing, 3.0. 3.0 has been released. What is up with GitHub right now? There we go. 3.0 is released. And we got all these little things that are happening here. So it's exciting. It's really awesome stuff. I'm going to go over... so basically exceptions are in, Boost Leaf is out. I very much appreciated what Boost Leaf gave us for what it was there for, but I personally cannot have a talk that's happening in April about how exceptions are the thing that you ought to be using for your embedded systems code without putting my money where my mouth is. So that's why we need to move over to it. I might have said this many times before. I was going to go over how try catch works, but I honestly think that most people here, if you just go Google up C++ try catch, you'll understand what's going on there. A couple of things that people who come from different languages might not know, though, is that you can throw anything and catch anything. I believe Python, what was it? I think Python you can throw it, you can raise anything as well. But there are, I think, certain languages that only allow you to throw certain types of things. So that's a thing. Now, we don't want people just throwing random garbage in libhal or really any code base. So that's where the next section here comes into, which is I'm going to show you what the actual types look like. So let's go in here. We're going to go over to code. We're going to go over to libhal, and then we're going to go to error. So actually, before we can go there, one thing I'm gonna see if I can do is, let's see, let's go to here. Let's go to commits. We have release 3.0. That's just putting out the release thing. Where's the big one? Yep, libhal 3.0, breaking change. And now I'm going to look at like ADC. And you're going to kind of see some of the differences here. So number one, got rid of a header, but the couple things. So number one, we had a return type for almost everything, or a return struct. And the idea was that in the future, we could update these structures and expand them if we needed to, if we made a mistake. The problem is that that is an ABI break, a really hard ABI break. And because we ship binaries, this is not really acceptable. We can't just add new things to the return type. It would break everyone's code. So we removed those. And all the ones that just only had a single item in here waiting for new things to be added, I just made them the return value. Cool thing though, is if we did see an issue with this somehow and we needed to retrofit this specific interface for whatever reason, I believe adding in additional vtable entries after this one or sorry, after this one, shouldn't be an ABI break. You should be able to, so long as your code doesn't call the other stuff, or yeah, it should just work for the most part. You can't rearrange them though. But yeah, no, you can also see that result has been removed. So that means when you call read, it just gives you back the value. There's actually a lot of benefits to this, even with really fancy compilation and whatever helpers you can give. Having your stuff wrapped up in a result type, if you're accessing it directly within the object, that actually works out pretty well, so long as you don't unwrap it. But if you try to grab the item outside of it, it usually results in a move. Now, that may seem fine because it's not a copy. Now, for all intents and purposes of what we do, whenever we move something, it's going to be a copy. Just so happens that the other thing, we might call it, what's what we're looking for? Invalid. And then when it destructs, it doesn't destruct appropriately. But that's all to say that, like, that's still copying that has to happen. And it's still things that the compiler has to do, work it has to do going forward. Now, if it could just somehow like just alias the inside, which you could use like a reference to the inside of it, but I think that all gets really messy. That's all to say that now that we're just returning back a float, the compiler can do a lot of the easy work to just give back that float versus, you know, all the unwrapping stuff has to do with this. So that's that. That's just kind of how some of them changes look like. All the other code basically follows the same thing. Result gets removed, and then the return value gets removed. And any no discard for things that were empty originally basically goes away. Now, we have error HPP. And this is one of my favorite items here. Actually, I can show you over here. So let's go over to error. And I'm going to remove that. I'm going to do that. I'm going to zoom in a little bit. And it's a lot longer than it used to be, I'll tell you that right now. So we have a couple things in here. We have safe throw. Now, safe throw is really just libhal's throw function, which I'll have to look into ABI specific stuff. I think for the most part, this shouldn't be a problem. I'm going to do some investigating into this, but the main idea is that I have this throw function that I will have full type information for the thing that's thrown, and then I'll be able to do certain compilation checks on it. For example, if you wanted to use safe throw and you used it and your object was not trivially destructible, meaning that you have a destructor and is doing stuff like, for example, deallocating memory for any reason because the exception object itself allocated memory, we could just tell you no, you just can't do that because it only works with trivially destructible types. That helps us to remove entire categories of additional edge cases that we wouldn't want to worry about. For example, what happens if you try to like deallocate some memory and then for some reason, or you're trying to do some operation with your thrown object and it has an exception happen during the destructor. We can eliminate that happening just by not allowing destructors. So that's what happens here. Halt is the same as it was before, no difference. The real difference is some of the stuff up here. So if we go over to, this is the good stuff. All right, so we have HAL exception. It is the base class exception for all HAL related exceptions. It takes a error code and it also takes a instance. We have a couple of reserved 32-bit values that we can use to basically expand this exception object in the future. I don't know what I'll use these for, but maybe there'll be a utility for these. Or maybe they'll never be useful at all. Who knows? But I added them in, and now they're kind of just locked into the 3.0. So, yeah, you lose 4 times 4, 16 bytes by having this in there. And if we never use it, then it's just extra 16 bytes we just have to live with. Now, let's talk a little bit about what these are here for. Error code, the idea is that error code would be used for logging purposes. So if you just caught a HAL exception, you could just log it out. The other benefits with error code is that it also allows us to do stuff like this. So I'm actually gonna write this over here. Let's do avoid foo. Let's say foo does something, and we're gonna do try do thing here. We're now gonna catch HAL exception as a ref. We can actually catch as a const ref, and then p. I'm just gonna call it error. Yeah, I actually just realized that's const, and that's const. Great, great, great. Okay, cool. Is someone not muted? Can if you're not muted, can you make sure to mute? And then here, if this is int, because we're working with some C API, we could then do something like return p error dot error code, and then that would just return out an error code. So if we just want to like have a wrapper between C code and C++ code, and we want to kind of fall back to an error code that's known, like some these are all POSIX error codes, I believe. So if we want to do something like that, that could work. Why is it erroring out on me? Return value does not match. Oh, yeah, I'll just do. I mean, I could either static cast it into an int, or I could just do std error c, and that'll work. Maybe. I'm not sure why it's upset. I think this might just be VS Code being slow, honestly. There we go. Yeah, so that's a thing. I might move. I've been feeling like moving to something else, honestly, because of how slow VS Code has been. But yeah, so that's error code. It's kind of just there for that purpose. But we also have another one called instance. So instance, the idea here is that let's say you have a driver, and you have a specific driver that caused or saw the error. Would it be useful to know which particular object the exception came from? Now, I've been spending a lot of time thinking about what types of errors are even handleable. Like, many errors that come up are just not errors that you can even do anything about. When they happen, you just don't know how to handle them. Not all, but many of them can be. So where does instance come in? Well, maybe the thing that threw an error, something that you expected or knew in prior experiments that this thing errors out, and you realize that you can resolve this by running like maybe a power off, power on cycle, just power cycle it, and then it'll continue on running. Maybe just over time, eventually just kind of cracks out, just messes up. So in that case, if you had a list of these, what you could do is check the instance, compare it to some other object. So let's say we have, int a, let's assume, actually let's do struct s, some struct, then we have s, and then we just create an s. I could do something like this. I could do if p error dot instance is equals to the address of a, then I could do something about it. Do something here. Maybe there's a reset function. I can call the reset function. You're not meant to take the instance and directly manipulate it. You're meant to manipulate whatever. Let's do that. Reset. The idea is that once you figure out that these are equal to each other, you know what you're dealing with, which one you're operating on. You know that it's alive too. It's within your scope, and you can modify it. So long as the scope of the object you're comparing against exists, this will work. I can also change this to is instance, or is this type, therefore requiring you to pass in something, blocking this down a little bit more. But I'm going to leave it as instance here, and then maybe in the future I'll add a big old fat deprecated attribute. Deprecated. And then I can give a little message as to why it's deprecated and why you should use the other one. So yeah, that's kind of the idea of the baseline HAL exception. Those are the things that I found them to be the most useful. I will also add in that I don't believe that a stack trace or other things like that, or source location, are useful, because the exception unwinding routine can actually do all that work for you. So we'll know where we start, we'll know where we end. We can just record it. So that's what we'll be doing. That's what I'll be doing in the Cortex M exception runtime at some point in the future. I'm only gonna go over this example, and then you can read the rest. But here we have a no such device exception. The idea is that each one of these structs basically maps to an error code directly, and then we have a description on how to use it and what situation this happens in. And I explain here, like raised when a device was expected to exist but did not. How to recover from this? Well, here are situations in which you already know how to recover. Like if you're scanning for devices, you should get an exception when they don't exist, and you can just mark those as not existing. Polling after reset, there are some devices weird devices that you can give like a soft reset, and then you have to pull them in order for them to come back online. And when their address comes back online and they're able to talk, they'll be ready to go. So you can pull on them. And you have like a number of attempts, and you can keep doing this until eventually this works. And if a different exception happens, then you can let that just pass through because you don't know how to handle that. You know how to handle no such device, but you don't know how to handle IO error or something like that, some other issues. And then probe does this for you, so you don't have to do it yourself. This is acceptable if you discover that the device sometimes just is intermittent. So you just know like, oh, this ever happens, just retry. And then otherwise, if this happens, then there's nothing you really can do. You can keep it, you can go a little further. So if you've worked with I2C, you know that if you try to talk to a device, you send out its address, and then it acknowledges you. But what about situations where it's not just, the first talk? What if it acknowledged the address, but then you tried to figure out its ID and you realize it's a different device? It just doesn't fit the expectation that you have. That is also no such device, because you look at it, you try to verify it, it didn't get verified. That's not the device you're looking for. These aren't your droids. So that is what this particular exception, when this exception should be thrown, so that users know exactly what they're getting themselves into when they receive this or when they're trying to catch it. And we have this for basically everything here. Some of these just basically say like IO error, that only in very specific situations can you know what that means for this to be recoverable. In most cases, it's not. A case where this could be recoverable is you're literally doing testing to see how long, you're probing to see how long or how fast you can communicate until the I2C device clocks out or doesn't work anymore, or how long a distance can be between the channel that you're using to communicate until it has problems. That could be reasons why IO error can be recoverable. Otherwise, if you don't understand that, then that's a problem. Your program, something with the hardware is messed up. And that's pretty much the errors that we have. So let me go back to here. Okay. All right. So that is the new error handling system. If you look around, I'll show you some of the things that we've already worked on, but I've already merged or migrated over.
Hey, so is there a non-safe throw?
Just use throw then.
It's just a normal throw?
Yeah, just throw. Yeah.
Oh, okay.
If you look at safe throw, it just does throw. That's all it does. It just throws whatever. Just throw keyword. Yeah. Yeah. So C++ error handling techniques. Now, I may not have time for this, so I'm actually going to skip this one for now. I might move this to the next meeting. But I'll talk about rethrow and when you'd use it. Set terminate, something that you should probably, if you're writing an application that's doing anything reasonable, you should probably set up a set terminate. The idea there is that what I've realized when it comes to error handling is that there are a set of errors that you can handle, and there's certain errors that you cannot handle. And I hope to have tooling that can tell you what errors are available in your code that get thrown, that you can know you need to either handle them or not. But in situations in which you're like, yeah, I don't know how to handle this. I don't know what to do with an IO error. It's not really something I could do anything about. That's fine. Have your set terminate, recover from that, or reset the device or do something. And I'll go over lib and cut later. All right. libhal 3.00 migration progress. So libhal's been migrated, libhal util's been migrated, libhal mock's been migrated, libhal soft, MPU, LPC40, those have been migrated. The rest, not yet. I have migration docs, so if anyone would like to help out, that'd be great, although they're not complete yet, so just keep that in mind. I will tell everyone, like, hey, looking for people to help out with migration. Here are the migration docs. Here's how you do it. And one of the reasons why is because I realized that this is probably the best time to go over libhal bootstrap and also talk about what it is that bootstrap's going to help us with. So just so you guys know, I am not also immune to some of the annoyances with working with libhal, or specifically working with Conan. There's a lot of things. In order to blink an LED on an MCU, there's a lot that is required to happen. A lot. It's not very simple. And what we're trying to do is put that, kind of compress down that complexity and make it easy for people to use. The problem with that is I think it's a very bad idea to do this too early. If you do this too early, you come up with this really cool idea and all these different use cases that you're trying to think about that may happen, and then a lot of them may not happen, or some of them were bad assumptions and all of that. So what I've been doing is just kind of waiting to see as the code base grows to see what things are super common. And I think I've found it and I have a way to solve it. So what I'm going to show you is I've been modifying MPU to utilize a thing called a Python require package in Conan. So yet another construct in Conan that's been there for a while. But now we're going to start actually utilizing. So what I'm going to do is I'm going to show you what, let's see if I can actually commit this so that I can see the delta. Log, yeah, amend, cool. And now what we're going to do is look at the timeline, and we're going to look at, is this one? Yeah, cool. So before, demos would have, actually, let me see if I can look at this exact file. Let's see if I can copy. I don't know what that does, actually. Okay, so the demos, actually, let me just give you another example. So let's go over to LPC40. We can go to its demos, then we can look at Conan file. And we can see here we have about 51 lines, ignoring like the copyright notice. But yeah, no, we have about like 51 lines. And all this is typical boilerplate, just typical boilerplate. We do it every single time. Everyone's going to include CMake. Everyone's going to include the libhal CMake util. Pre-built pico libc is required in order to re-enable exceptions. And then whatever else the things you need to include. So I was like, all right, well, there has to be some way to reduce this. And I remember talking to the creator of Conan, and they was like, yeah, you might probably want to use a Python requires for this. So this is what it turns into. You just do from Conan import Conan file, class demos, Conan file. Python requires bootstrap, whatever version you want. I should probably make this actually a range. Then you can say extend. You just say libhal bootstrap demo. That's the class that we extend from. You have to do this. This will basically grab the Python module and then allow you to call functions that are inside of it. And this will add all of the demo requirements, including like whatever's required for your platform to operate. So the details of this, file, where's bootstrap? Is that I want to have this list of every single platform that really will exist. And then when you use demos, it'll automatically choose the appropriate requires function for, in this case, if your platform starts with LPC40, we can just map that to be, we'll include this for you. So the users who create these demos do not have to figure out what are the set of platforms they need to support. All they need to do is write the implementations here and they're good to go. Maybe I'll also have some demo-based versions of these in the future so that people won't have to build these anymore. Maybe I can package that in with libhal LPC40. Whoops daisy. But still, I'm looking at ways to package stuff down that we currently use now. And yeah, basically the constructs that we have now that are working really well and package them down. So that is libhal bootstrap. I want to do this for everything. So that's going to be, for this one, we have it for demos. It should be this small. I want to do the same thing for our libraries as well. I wanted to condense all of this, the majority of this down to just almost this. Maybe the only things that it will do extra will be like package info. And this will be the same, so don't need it. This will be the same, so don't need it. This will be the same, so don't need it. We'll probably have our own requirements, so that's fine. I might actually leave this one alone completely. This boost UT is going to be in there. Mock will probably be there. Util will definitely be there. This should actually have CMake as, what the heck? Oh, CMake should definitely be in here. This will help with that too, so we don't make mistakes like this. And then validation. And then everything else here. Everything else here will be part of that. I think the only thing that'll stay here is probably this stuff, which is metadata, which isn't really unique. So yeah, everything that's not unique here will be crunched in. And I hope to do the same thing for libhal starter, so that when you do a starter project, it feels like as simple as this. And all you need to do is maybe copy that portion and then add your special bits. Add your special bits after this point. So yeah, that's libhal bootstrap. I think it's going to make our lives a lot easier. And make refactoring a lot easier. And yeah, I think it's going to be great. So that's the exciting bit there. And where is my, oh, there it is. Okay. And then finally, I want to talk about something that I've been kind of noticing. And I want to make sure that we are protected against this. So if libhal takes off in the future, people start actually caring about it and actually start finding it and doing stuff with it. I plan to lock down libhal to a walled garden. Still going to be open source, not going closed source, not about that. But we will try to, basically the only people who are going to be allowed to make issues, well, yeah, the only people who we will allow to make issues, to discuss things and all stuff like that, will basically be people that we know are human. Because the future is going to be full of GPT enthusiasts, desperate developers trying to get a t-shirt, tutorial followers, bots, and state actors. If libhal becomes very large, state actors become a big problem. They'll be like, oh, well, if we know that some government agency decided to use libhal, or some companies that they're interested in harming or having control over are using libhal and any of their technologies, they could try to slip in a very innocuous bug that could slightly give them a little bit of an exploit that's hard to read and then give them some sort of control. They know how to exploit it from that point on. I am certain that with the future of bots, we're going to get a lot of garbage code that comes in. Now, you're probably thinking to yourself, well, won't the bots get better and won't they write better code? Well, no, because the bots only know what code they have written in the past. I have tried to get the bots to write code for libhal, trust me, and they're awful at it. They are so bad, and if someone were to send that code to a PR to me, I'd be very upset, because there's no way that ChatGPT is going to be able to write decent enough and precise enough algorithms and code that we will be able to accept in. I just don't think AI models are good enough to support that thing. I think they're great as a tool for humans who are already good to get better. I don't think just asking to write a USB driver and it'll come up with anything useful. That's an example of one. Oh, question? Oh, someone's mic is on, FYI. Tutorial followers. So before I go any further, this information I'm going over is actually in these two. I know a lot of people have feelings about Jonathan Blow. He's an interesting guy. I like listening to his takes. Don't always agree with everything he talks about. Theo, I think I agree with most stuff that he talks about, honestly. But he has a video called Don't Contribute to Open Source, and he explains to people who are not in open source why they shouldn't just go and contribute to open source. This doesn't mean anyone who's here, you guys have projects that we're working on, but basically, there was a YouTube video of someone going over a tutorial and explaining how to do something, and then everyone went and followed that tutorial and made a whole bunch of PRs against a lot, like Express.js specifically. And that can be a problem. Some people, I think, GitHub had contribute to open source and get a free t-shirt type thing. And people want to update their portfolio, and they want to do stuff. And they just want that t-shirt. They want those little prizes. So they'll just put a whole bunch of garbage around to update certain things here and there. And it gets really annoying and it becomes a problem. And then finally, people who just don't want to do the real work and just want to use ChatGPT to give the entire answer. Hey, let me tell you something real quick. I don't care if you use ChatGPT to help yourself to write drivers for libhal or whatever you're doing. I think that's actually perfectly fine. I think the problem doesn't lie with the tools that you use to get there. It's whether or not the outcome is good. And I think that a lot of people who are desperate, or really not desperate, but in a way lazy, or don't understand stuff well enough and are hoping just to get a PR through, we'll just use ChatGPT and say, hey, make this thing for me, and then try to submit it, and I'll be like, no, not at all. So yeah, that's how I feel. That's why I want to make libhal a walled garden. I think that's the only way that that open source projects are going to be able to survive in the future. So I want to kind of get on that now. But so long as I meet you in real life and you're a real person, and I think that you don't have any malintent, I don't see why you can't be part of the open source crew. And that's about it for this week.